In this video, I introduce asynchronous methods for deep reinforcement learning. Reinforcement learning agent uses a policy pi to map from states SAT to actions AT that maximize the accumulated reward return RT, where gamma is the discount factor. The value of a state S and policy pi is defined as V pi S, and the state action value Q pi S A is the expected return for selecting action A in state S and following policy pi as defined here. This is a value at state ST. This is the state action value Q at the state ST following policy pi. The optimal state action value is reached by taking maximum action as shown here. In the value-based model-free reinforcement learning, one-step Q-learning optimizes the model parameters set to minimize the loss error as shown here. This target, this state action value. Policy-based model-free method directly optimizes the policy pi by updating theta through gradient ascent on expectation RT. Namely, we update theta using this formulation where the gradient is calculated from this formulation. If we use state value V to replace this baseline, then this term will become advantage function A. Introducing the baseline BT is to reduce the variance. Asynchronous advantage actor-critic is a deep reinforcement learning framework that uses asynchronous gradients from multi-CPU threads on a single machine to optimize deep neural network policies. The asynchronous process reduces the time correlation similar to the experience replay buffer. As shown here, each thread interacts with his own copy of the environment, and at each step computes a gradient of the objective function as shown here. The target network is thoroughly changed as in deep Q network training, as shown here. A3C accumulates a gradient over multi time steps before they are applied, similar to using mini-batch as shown here. A3C maintains a policy pi and estimate of value function V as shown here and here. The policy gradient is updated by using this formulation where A is the estimate of advantage function given by this formulation as shown here, where K can vary from state to state and is upper banded by T max. This is synchronous gradient computation. This is the environment and these copies of environment. This threads in a single CPU, and then we put them together to update the overall model parameters. For more details, please check with these references. Thank you. Bye.